Have you ever wondered how all the computers in your school lab can talk to each other without it being a complete disaster? Well, there's actually a secret map for that, and today we're going to uncover it. So here's our game plan for today. We're going to start by figuring out what exactly network topology is. Then we'll check out the two different ways we can map a network. After that, we'll dive into the four main layouts you absolutely need to know. We'll even see how this all applies to your school, and we'll finish up with a super handy revision guide so you're totally ready for your exams. All right, first things first. What in the world is this thing called network topology? You can think of it like a blueprint, or maybe the rule book for how every single device in a network gets connected. Just look at this. It's a perfect analogy. On the left, you've got this messy, chaotic jumble of desks. Total chaos, right? But on the right, everything's in a neat, organized structure. Well, a network topology does exactly that for computers and all their connections. It literally turns digital chaos into a clear, organized system. Okay, time to get your highlighters out because this is the key definition you absolutely, positively need for your exams. So, network topology is the interconnected pattern of network components. And in a simple local area network or LAN, like in your school's computer lab, it's basically just the cabling structure or the pattern of the computers. Now, this is where things get really interesting. You see, there isn't just one way to map out a network. Nope, there are actually two. So let's explore how these different maps give us the full picture. Okay, so on one hand, we have physical topology. The easiest way to think about this is like the actual floor plan of your classroom. It shows you exactly where each computer desk and every single wire is physically located. But then, on the other hand, you've got logical topology. This is more like the rule for how you're allowed to pass notes around the room. It describes the path that the data actually follows, and get this, it might be totally different from the physical layout. And this image here shows the difference brilliantly. Physical topology, that's all about the actual hardware, the stuff you can see and touch, the computers, the cables. But logical topology, that's about the invisible path the data takes, kind of like that winding snake, showing how the information flows through the system. All right, now for the really fun part. Let's explore the four main ways you can arrange those desks in our network classroom. These are the fundamental patterns that you've just got to know. Okay, layout number one is the bus topology. Now, this is one of the simplest and, oldest network designs out there. It's a really fantastic starting point because it kind of forms the foundation for understanding the more complex stuff. So imagine you've got one really long table and everyone is sitting on one side. That's a bus topology. Every single computer connects directly to one single main cable, and we call that cable the backbone. All the communication just travels up and down that central line. Next up, we have the star topology, and I can pretty much guarantee this is the most common type you interact with every single day. I mean, your home Wi-Fi network? That's a perfect example of a star topology in action, with your routers sitting right there in the center of the star. Think of this one like arranging all the desks in a circle around the teacher. Every single device connects to one central point, which is usually a hub or a switch. And all the data? It has to pass through that central device to get where it's going. Okay, let's look at another classic setup. It's really important to understand this one, even if you don't see it as much today. We're talking about the ring topology. Just imagine passing a note around a perfect circle of desks. The note has to go from one person to the next, and it only goes in one direction, until it finally reaches its destination. Well, that is exactly how a ring topology works. The data just travels from device to device in one continuous loop. So let's think about your school's network for a second. Which one of these layouts do you think it uses? The bus, the star, the ring? Well, the answer is probably a mix of them. And that brings us perfectly to our fourth and final type. And that brings us to layout number 4, the hybrid topology. Now, this is the one you'll see most often out there in the real world, especially in big places like schools or offices. You could say this is where theory meets reality. So a hybrid topology is, well, it's exactly what it sounds like. It's just a combination of two or more different layouts. And honestly, this is the most practical solution for the real world. Why? Well, because it lets network designers use the strengths of different topologies exactly where they fit best. For example, your school might use a super reliable star network in each computer lab, but then all those separate stars connect to a main bus network that acts as a backbone, maybe running down the main hallway. See? You get the best of both worlds. All the reliability you need in the labs, plus an efficient way to connect everything together. Okay, let's switch gears a bit. We're going to focus now on exactly what you need to know to absolutely ace your exams on this topic. So pay close attention here. This is the important stuff. I can almost promise you'll get a comparison question like this on your exam. A fantastic way to compare them is to think about what happens when something breaks. So in a star topology, if one computer's cable fails, no big deal. Only that one computer goes offline. Simple, right? But if that central hub fails, the entire network is down. Now, let's compare that to a bus topology. If that main backbone cable breaks anywhere along the line, the whole network stops working. Understanding that key point of failure, that is absolutely crucial for getting top marks. Okay, let's boil all of this down to the absolute essentials. If you can explain these key concepts clearly, you are in fantastic shape for your exam. So just remember, topology is simply the layout or pattern. You've got the physical map, which is for the hardware you can actually see, and the logical map for the data's invisible path. And of course, you've got the four main types we covered: bus, star, ring, and hybrid. And here it is, your ultimate cheat sheet. Let's just do one final check to make sure you've got it. The main idea? Topology is all about the layout or the pattern. You need to know the two ways of seeing it: the physical map for the hardware versus the logical map for the data's path. And of course, the four fundamental shapes: bus, star, ring, and the one you'll see everywhere, hybrid. If you've got that down, you've totally got this. And hey, what's a revision guide without a good memory trick, right? To remember the four main types, just think of this super simple phrase: brave students raise hands. That's B for bus, S for star, R for ring, and H for hybrid. How easy is that? And that wraps up our journey through network topology. You now understand the secret, invisible map that connects our entire digital world. So I'll leave you with this question to think about. Based on everything you've just learned, what kind of topology do you think is connecting your device to the internet right this very second? Give it some thought.
Have you ever thought about how all the houses in a neighborhood are connected by the same main road? Well, it turns out some computer networks work in a really similar way, using just one shared path for everything. So, that really makes you wonder, right? How in the world do all these different devices, your computer, your printer, you name it, share one single road for all their information without causing a massive traffic jam? Okay, so here's our game plan. First, we'll cover exactly what bus topology is. Then, we'll look at how you build one. After that, we'll get into its advantages, and we'll wrap it all up with a quick cheat sheet to help you ace your exams.
All right, let's kick things off with the absolute basics. What exactly is bus topology? Nailing this definition is super important.
So what's the big idea? Well, put simply, a bus topology connects every single device using one single cable. If there's one thing you take away from this, let it be that. That single cable is the heart and soul of this entire setup.
And you know what? That main cable actually has a name. It's called the bus. It's the backbone for the whole network. The name is perfect when you think about it. It's just like a bus route, you know? There's one main road, and all the stops along the way, which are our computers, are just connected to that one path.
Okay, so we've established it's all about that one cable. But what else do you actually need to build one of these networks? Let's take a look at the key components.
First up, you've got the devices themselves. Any computer, any printer, any gadget at all that's hooked up to that main cable is called a node or a network device. I know it sounds a little technical, but it's just the official term for anything connected to the network.
Okay, this brings up a pretty logical question. If data is zipping down the single cable, what happens when it gets to the very end? What's to stop it from just hitting a dead end and bouncing all the way back, kind of like an echo in a hallway? That would cause total chaos for all the other data on the line.
Well, the solution is a clever little thing called a terminator. You attach these small pieces to both ends of the cable, and their only job is to absorb the data signal, stopping it dead in its tracks so it can't bounce back. Without them, the network just flat out wouldn't work.
And you know, this very specific setup, one cable with a terminator at each end, has an official name. It's called a linear bus topology. And yep, that's definitely a key term you're going to want to remember for your exams.
All right, let's move on to Section 3. Now that we know what a bus network is and how it's put together, let's talk about the advantages. I mean, why would anyone actually choose this setup over all the other options out there?
So, why use it? Well, the first big reason is cost. Because you're only using one main cable, it is way cheaper than other designs that might need a separate wire for every single computer. The math is simple, right? less wire equals less money. And yeah, this piggy bank image really drives that point home. So from now on, when you think of bus topology, I want you to think budget-friendly and efficient.
But hey, it's not just about saving a few bucks. Bus topology is also really simple from an operational standpoint. The whole design is easy to understand, which makes it perfect for smaller networks, like in a small office or a school computer lab. Plus, on top of that, it's actually really easy to add new computers to the network. For instance, if you decide you need to add another computer, you don't have to redesign the whole network. You literally just connect it to the main bus. It's as straightforward as that.
Okay, we have covered a ton of ground, so let's get to our final section, the one I know you've been waiting for. Section 4, the exam revision cheat sheet. This is where we're going to pull everything together into a quick, easy-to-remember summary.
This slide basically puts it all in one place. You've got the single cable, you see the terminators at each end making it a linear bus, and it points out those key features, that it's cost-effective and easy to expand. It's a fantastic visual recap.
So if we boil it all down, here are the top 3 things you absolutely need to remember. Number 1, it uses a single main cable called the bus. Number 2, it has to have terminators at both ends to work right. And number 3, it's the best choice for networks that are small, simple, and need to be low cost.
And just to make sure all of this really sticks, here's a little memory trick for you. Just think of the word BUS. The B stands for backbone, that's single shared cable, and the US can stand for U stoppers, to remind you that you need to use those terminators or stoppers at the start and the end. It's a simple little trick to help it all click into place.
All right, let's get right into it. Have you ever walked into your school's computer lab, you know the one, and seen all those PCs just sitting there all lined up?
Ever wonder how they all manage to talk to each other? Like, how do they all get online and connect to that one printer all at the same time? Well, that's where something called network topology comes in. You can basically think of it as the map of the network. And today, we're going to zero in on the most common one and a super important one for your exams, the star topology.
So here's our game plan. We'll kick things off with what it actually is, then we'll look at the key players, figure out why the switch is so important, cover the biggest advantages, and then we'll wrap up with a quick revision session so you're totally prepped for any exam questions. Sound good? Let's do it. All right, first things first. What in the world is a star topology? Let's get this core idea locked down.
Okay, get your highlighters ready because this is a big one for your exams. A star topology is just a network setup where every single device, we call them nodes, is plugged directly into one central gadget, usually a hub or a switch. And here's the really key part. Every single connection gets its own private cable, no sharing. It's a one-to-one deal.
And this little diagram, it shows it perfectly. You've got your node, which is really just a fancy term for your computer or maybe a printer, anything on the network, right? And it has its own direct line straight to that central device. It's this simple, clean, star-like shape that makes it the go-to setup for most networks you'll see out there.
Okay, so we've got the basic layout down. Now let's meet the 2 key players that make this whole thing work.
So let's make sure we're crystal clear on who does what. First, you've got the node. Think of these as the endpoints of the network. You know, the actual computers you use, the printer you're trying to send your homework to. Then you've got the central device. This thing is the absolute heart of the star. It's the central meeting point where everything else connects. And you know what's pretty cool? The whole setup is super flexible when it comes to cables. A star topology isn't fussy at all. It can use those standard twisted pair cables you probably have at school, or blazing fast optical fiber, or even the older coaxial kind. That ability to adapt is, you guessed it, another huge reason it's just so popular.
Right, now let's zoom in a bit on that central device, because it's not just a dumb plug, it's way more than that. Let's talk about the switch, which is basically the brain of the whole operation.
See, a switch doesn't just sit there. It's smart. It actively manages all the data zipping around, making sure information goes only to the computer that actually asked for it. But it also has another super important job. And this is a key word you absolutely need to remember. It acts as a repeater.
So what the heck is a repeater? It's actually pretty simple. Think about it. When a signal travels down a long cable, it starts to get tired. It gets weaker. A repeater is like a little energy booster. It grabs that fading signal, pumps it back up to full strength, and then sends it off again. This is what keeps your connection feeling snappy and strong, even if the computer is pretty far away.
Okay, so we know what it is, and we know how it works, but the big question is, why? Why is this setup so incredibly popular? Let's dig into the biggest advantages of the star topology. Really, it all comes down to three main things. Star topology is fast, it's simple, and it's super, super reliable. First up, advantage number 1, performance. Remember how we said every computer gets its own dedicated cable? Well, think of that like having your own private highway to the central switch. There are no traffic jams. The data from your friend's computer isn't going to get in your way and slow you down. All that means less traffic, which means higher speeds and a way better network experience for everybody.
Okay, on to advantage number 2, maintenance. Seriously, for anyone who has to manage a network, this setup is a total dream. It's easy to get it all set up. It's a breeze to add a new computer or get rid of an old one without having to shut everything down. And here's the best part, it's so much easier to figure out what's wrong. If one computer is having issues, you know the problem has to be either that computer or its specific cable. Simple.
Now this leads to a really important question, and it's the kind of thing that loves to pop up on exams. So what happens if one computer's cable just breaks?
And here it is, the STAR's biggest superpower, fault tolerance. This is our third advantage, and trust me, it is a huge deal. If one computer or cable fails, it doesn't matter. It does not take down the rest of the network. Everyone else just keeps on working like nothing even happened. The network stays up. This kind of reliability is a massive win in the real world, and I can almost guarantee you'll be asked about it on a test.
Okay, let's pull all of this together. It's time for a super quick revision session to make sure all this stuff sticks. This mind map right here is your new best friend for studying. You can see everything in one spot. You've got the main definition, the hardware we talked about, the key tech like the switch acting as a repeater, and of course, all those awesome advantages. Fast, easy to manage, and most importantly, safe if one part fails. Look, if your brain is full and you can only remember a few things, make it these 4 points for your exam. Number 1, every device connects to a central hub or switch. Number 2, that switch acts as a repeater, boosting the signal. Number 3, it's easy to set up and fix problems. And number 4, the absolute key takeaway, if one device fails, the rest of the network is perfectly fine. That's fault tolerance. Remember that term.
And hey, if you need a little trick to remember it all, just think of an actual star, right? All the points of the star connect to the center. If one of those points burns out, the center is still there and it keeps all the other points shining.
And that's star topology in a nutshell. I'll leave you with one last thing to chew on. Now that you get how this structure works, where else do you see it in your daily life? This idea of a central hub with a bunch of things connected to it. I bet you'll start noticing it everywhere. Thanks for tuning in, and good luck on those exams.
All right, hello and welcome. If you've got exams on the horizon, then you know just how important it is to nail down network topologies. Today, we're going to completely master one of the big ones, ring topology. So let's just dive right in. You know how it goes when you pass a note in class, right? You get it, you read it, and you pass it to the next person. They do the same, and it just keeps going around in a circle. Well, that super simple idea, that's pretty much exactly how some computer networks work, as a perfect circle where information gets passed from one point to the next. Okay, before we dive into the ring part, we got to get one key term down that you'll definitely see on your exams, network topology. All this really is the map of a network. It shows you how all the computers and different devices are connected to each other. Once you get that map in your head, understanding what a ring is becomes a whole lot easier. So, here's our game plan. We're going to start with what ring topology is, then we'll look at how data actually travels around it, why you'd even use a ring in the first place, how these networks get bigger, and we'll wrap it all up with a super focused revision to make sure you are 100% ready for your exam. Okay, first section, let's really break down the basic shape and the parts that make it up. What actually makes a network a ring? The main idea here, the absolute core concept, is a closed loop. See, in a ring topology, every single computer is connected to exactly two others, one on its left and one on its right. And that setup creates this continuous unbroken circle for data to travel on. And here is the really critical part. The chain doesn't have an end. The very last computer connects all the way back around to the first one, and that's what completes the loop. So you get this perfect circle with no official start or finish. You might be wondering, how does all this data move so quickly? Well, a lot of the time, these networks use high-speed fiber optic cables. They're built specifically for really fast and efficient data transfer, which is a big part of what makes the ring network so speedy. So we've got our circle of computers, right? But how does the information actually get from your computer to someone else's? Let's take a look at the rules of the road for a ring network. Okay, rule number one, everybody's equal. There isn't one big boss computer that's in charge of everything. Nope. Every single device in the ring has the exact same job. It receives data, and then it passes that data along to its neighbor. Everyone plays an equal part in keeping that information flowing. And that brings us to how the data moves. It's done sequentially. Just like that parcel or that note we talked about, a packet of data starts its journey and moves from one computer to the very next one in the line, then to the next, and so on. It's a really orderly, step-by-step process. Okay, now this is a huge one for your exams, so really listen up. Data can only travel in one direction. That's it. Think of it like a roundabout where all the cars have to go the same way. This one-way rule is absolutely essential because it stops data packets from crashing into each other, which keeps the whole network organized and running smoothly. So, a one-way street? That sounds a little restrictive, doesn't it? But believe it or not, this simple rule actually leads to some massive advantages. Let's break down why this setup is so good and pay close attention because these are the kinds of things you'll definitely want to have in your back pocket for the exam. Advantage number one is steady performance. Because the data flow is so organized, one packet after another, all in one direction, the network just doesn't get overwhelmed. You can have tons of data moving around, like really heavy traffic, and the performance stays stable. No traffic jams here. Second, these networks are really easy to expand. If you need to add a new computer or a node, as it's called in networking, you can just plug it into the ring without causing a big meltdown. The network stays stable, which makes it super simple to grow. And the third big advantage? Well, this one's a big deal. It's cheap and it's easy. The cost to install one is usually pretty low, and the setup is much more straightforward compared to some of the more complicated network designs out there. That makes it a fantastic choice when you need a reliable network, but you're on a tight budget. Okay, so it's cheap, it's stable, and it's easy to expand. Sounds pretty great. But that expansion brings up a really interesting question. We know we can add more computers, but what happens when the ring gets really big, maybe connecting machines across an entire school campus? Well, there's a pretty clever solution for this exact problem. I mean, think about it like this. If you whisper a message to a friend, and they whisper it to the next person, and they whisper it to the next, what happens? Eventually, that message gets fainter and fainter, doesn't it? The exact same thing happens to a data signal when it has to travel a really long way. So what do we do about that? The solution is this clever little device called a repeater. You place a repeater somewhere along the ring, and its job is super simple, but absolutely vital. It catches a weak signal, boosts it back up to full strength, and then sends it on its way. This makes sure the data stays crystal clear and strong, no matter how huge the network gets. Okay, we have covered a lot of ground. Now it's time to switch gears into full-on exam revision mode. This is where we lock in everything you absolutely need to remember. Think of this slide as your ultimate cheat sheet. We've talked about the structure, which is a closed loop. We've talked about the logic, that sequential one-way data transfer. We've talked about the tech, those fiber optic cables, and the all-important repeaters. And of course, the pros. It's cheap, easy to expand, and it handles traffic like a champ. So here's the bottom line. If a question about ring topology pops up on your exam, these 4 points are your golden ticket. Remember the definition, remember the one-way data flow, remember the 3 main advantages, and remember how repeaters help it get bigger. Seriously, memorize this slide and you are good to go. And just to make sure this all sticks when you're under pressure in an exam, here is a simple memory trick using the word ring itself. R is for round, just like the circular shape. I is for in order, because the data moves sequentially, step by step. And NG can stand for no gridlock, because it handles all that heavy traffic so well. So just remember, round, in order, no gridlock. You've got this. Good luck. All right, today we're going to dive into something called hybrid topology. Now, I know it sounds super technical, right? But trust me, it powers almost everything around you, from your school's computer lab to huge company offices. And by the end of this, you're going to get it completely. So let's jump right in. So, have you ever stopped to think about how your school's network actually works? You've got computers in the lab, in the library, in the office. They all need to talk to each other. How do they connect all those machines without it turning into a total mess? And more importantly, how do they make sure one little problem doesn't crash the whole thing? Well, that's where this clever idea, hybrid topology, comes into play. Okay, first things first, what even is hybrid topology? Let's get straight to the definition. And hey, quick tip, this is a big one for your exams, so you'll definitely want to listen up. And there it is, super simple. A hybrid topology is basically a mix and match of network designs. You know how you have different types of networks, right? Like a star, where everything connects to one central point, or a bus, where everything's on one main line. Well, a hybrid just takes two or more of those different types and smashes them together into one big, super efficient network. The main thing to remember is that word combination. It's never just one type. This picture nails it. It's kind of like playing with Lego, you know? You don't just use the one type of brick. You use the flat ones for the base, the tall ones for the walls. You mix them up to build something awesome. That's exactly what a hybrid network does. It combines different styles, like a star and a ring, as you see here, to build the best possible network for a specific job.
All right, so we know what it is. Now let's get to the fun part. How do you actually build one? We're going to walk through a really common example, something you'd probably find in your own school.
So let's start with the basics. Picture two different parts of your school, say the science department and the library. Each one has its own little network setup as a star topology. You know, all the computers in that room are connected to one central device, like a hub. At this point, they're completely separate. They're like two little islands. Okay, so how do we connect those two islands? We build a bridge. In networking, we call this bridge a backbone. It's like a main highway that connects the two departments. And here's the magic trick. That backbone is a different type of network itself, maybe a bus or a ring. So you've got two star networks connected by a bus network. See? Star plus bus, and boom, you've got yourself a hybrid topology. So we know what it is, we know how it's made, but why bother? What makes it so special? Well, this is where we talk about its superpowers. These are the key features that make hybrid topologies so awesome. First step, scalability. That's just a fancy word that means it's super easy to make the network bigger. Let's say your school gets a bunch of new computers for the science lab. No problem. You just plug them into the hub that's already there. You don't have to mess with the library's network or the main backbone at all. It can grow without a total meltdown. Next superpower, reliability. And this one is a lifesaver. Look at this diagram. One computer has a problem, right? Its connection is out. Now, in some other network setups, that could be a catastrophe. It could bring everyone down. But not here. With a hybrid setup, the problem is isolated. The rest of the library computers are fine, and the science lab doesn't even notice. Everything else just keeps chugging along. And finally, superpower number 3, speed and efficiency. Because you're mixing and matching, you get to pick the best parts of each design. So you can have those simple, easy-to-manage star networks in the departments, but then use a super fast, heavy-duty bus or ring for the backbone to transfer big files between them. You literally get the best of both worlds. Okay, time to wrap this up and get you ready for any tests. This is your exam-ready revision. So if you've been taking notes, get ready to add the most important stuff right now. And here you go. A perfect little cheat sheet for you. This sticky note has everything you absolutely need to know. The definition, how it's built, and its main good points. I'm not kidding, this is the moment to hit pause and jot this down. It's pure exam gold. All right, let's run through it one last time to really make it stick. What's the definition? A mix of two or more topologies, like star and bus. How's it structured? Smaller networks, like stars, connected by a central backbone. And what are its 3 superpowers? 1, it's scalable, so it's easy to add stuff. 2, it's reliable, so one mistake doesn't break everything. And 3, it's efficient, because you get the best of both worlds. Easy, right? And if you ever get stuck, just remember this one simple trick. Think of a hybrid car. What does it do? It uses 2 types of power, right? Gas and electricity. A hybrid network is exactly the same idea. It uses 2 or more different types of networks. That's all there is to it. Hopefully that makes hybrid topology crystal clear. Thanks for tuning in.